Hi, welcome to How to Repair. Today I went down the nursing home to visit my mother, and the owner of the nursing home had thrown out a couple of these tea urns or water boilers, canteen water kettles or whatever you want to call them. And one was a Swan and one was a Buffalo. And I stripped them down to have a look at what the fault was. On both of these tea urns, they had fitted fixed elements to the tea urn. In other words, you can only buy the whole piece, which is absolutely ludicrous. So luckily I had in stock a old Burco tea urn element, which is 2500 watts. And I actually know that there's enough room to fit one of these in. So I'm going to show you a hack to actually convert your original tea urn into a conventional element type. The Chinese are now manufacturing these and they're shipped over from China, and you can only buy the whole blooming water container, which is about £120, which is ludicrous when an element only costs you £15 to £20. It's just another example of built-in obsolescence. So let me show you a hack on how to fit this element and how to diagnose the fault with the actual tea urn. Now the first thing you'll notice is you've got a thermostat and you've got a couple of lights, one to say it's at temperature and another light to say it's actually heating. Now the first thing you want to listen for is when you turn the thermostat, you can actually hear a clicking noise from the thermostat. Now when I looked at my ampage meter at the top here, it wasn't drawing any power. This means that the thermostat is coming on, but there's no power being drawn, which normally is a sign that the element is open circuit. So let me take it apart to do a test to show you where the element is and how to check it. There's also reset buttons on these tea urns as well that you need to be aware of if they overheat, and will fit a conventional Burco boiler element to this tea urn. Okay, we have the tea urn. I've taken the lid off, emptied it of water, and if you turn it over, you have a reset button at the bottom which resets a thermostat. Now you can only actually see one screw on this tea urn. Normally the base of these come off, and you actually need to remove a few pieces of plastic to give you access to the screws. Okay, so if you use a little spiky screwdriver on this Buffalo type, you have to get in and remove little plastic trims inside the feet, and we'll just go around and do all these, and then you can see there are 4 screws hidden underneath. Now with these, they're normally straightforward. Just undo the screws, remove the feet and take the feet off. This screw here is actually a security screw, and for some unknown reason they decide to fit these, and sometimes they are absolute buggers to get off. When I say security screw, just so I can show you this, it's an actual triangle, and you normally need to use a special screwdriver, but sometimes you can find a small flathead screwdriver that will actually fit in 2 of the corners. Now there's one more earthing screw here which has got a cable attached underneath. You just need to hold the nut underneath and remove the screw, and then that can be put to one side. I dropped the washer there. Now we have the element, as you can see, is actually, it's either some sort of chemical glue that holds it in place, or it's actually fused to the actual chassis. So to test the element, we're going to undo one of the terminals and remove the wires. And then we're going to use the multimeter on continuity, and we'll just check that we have continuity. And as you can see, when testing across the element, there is no continuity whatsoever. A new element will have continuity. I'm also going to set it to ohms, and yet again nothing. Now if I look closely at this element, I can actually see that it states 2600 watts on the element, and it's stamped on here. Now this new element, if I just show you, if we do the same test, check it to continuity and go across the two terminals, we have continuity. And if we check it to ohms, we can use Ohm's law, and we've got 23.4, which is telling me that this element is a 2500 watt. This is perfectly within the sizing capability of the wiring that's on this. I would suggest you never go really much above 100 watts either side of the existing element that's in the boiler, because maybe the wiring isn't up to the capability of carrying the ampage. Now we need to decide where the element is going to be fitted, and I want to get it central, but we do have some thermostat mountings here which I really do not want to get in the way of. So with a little Sharpie pen, I'm just giving myself a clear mark on where the thermostat lives. And the reason I'm doing this is when I fit the element, I do not want to actually have this thermostat interfering. So that's the reason why I'm doing that. Now we need to remove the thermostat, and I think these are 5mm bolts. So just undo this. This will allow me to take the safety or the cutout out, and now I can remove the thermostat. Okay, once I've got that off, I'm just going to remove the nut on the new one, and I'm going to use a micrometer just to work out what my hole size should be, and that's coming up 39 on the threads. I want it to be a tight fit, so I'm actually going to use a 38, hoping that it widens it out slightly. So I'm just going to undo the drill bit a second so I can mark it, and then I'm going to use my Sharpie again, and that is about center. And then I'll do a quick measurement on that to get my center, which will be somewhere around there. Okay, one of the things you want to check before cutting is get the nut off the element and make sure that it lines up on the hole and you have clearance on the studs. It is very important to make sure that this, when it's turning, does not touch the studs in any way. And we're quite happy on where that's going. Okay, I'm just going to put a little bit of cutting oil on where I'm going. And I'm just going to go nice and slowly, and I'm slightly moving this out. Okay, it's always sod's law, as they say. While I was cutting, I got through the steel part to the stainless steel, and I blunt the bit because I wasn't using the right compound. Now, although this is a multi-steel cutter, stainless steel is always very hard to cut. So I do suggest when you're using a cutter, make sure you use a good quality stainless steel cutter. Okay, I just put some cutting compound on, and we'll try again. Making sure you cut slowly. And that was quite hard to cut. Now we need to clean up all the edges and fit the new element. Okay, I'm going to give this a good clean and get rid of any of the burrs on the actual metal. And then we actually need to fit the new element, and then I'll need to clean this a few times to make sure all the oil deposits are completely removed, because this is actually used for boiling water. And there we go, we've cleaned up the surfaces, so now we'll drop the element in, and it's a nice tight fit. So I'm just going to rotate that while I put it down, and I think we'll have it on this side as it lines up nicely. And now we'll insert the nut on the other side, and we'll drop the seal down. And we can put the nut on, making sure not to cross thread it. Okay, I didn't have a socket the right size, so I'm using a set of grips, but I've held it tight on the other side. And you want to take this, just be careful of the fittings, and get that on, and give that a little twist up. Just give it a little twist. You want this tight, but not over tight. In other words, you only need to take it so it's watertight. And just squeezing that down now, giving it a turn, and that should be tight enough. I can see the seal compacting there. Now we need to transfer the wiring to the element. Okay, we are going to have to change some of these terminals to spade connectors, because the new element is a spade connector type. And what we'll do now is fit this thermostat back in first, and you'll notice I put some heat paste on there. So we'll just drop this down. And now we can put the two nuts on and get this done up. Okay, the first thing I need to do is put the earth wire on. It's quite fiddly on camera. Okay, we've got all that fitted. Now we've got to join these two red wires to a spade connector and these three white wires to a spade connector. Now the three white wires, I think I'm going to use two terminals on a piggyback. And when I say piggyback, I mean a piggyback connector. And then we'll need to put some heat shrink on that, and then they will join together. I'm not going to film this, I don't want to bore you, and it's going to take me 10 minutes to make good terminals on these. So I'll just get on with that and I'll do the connections. Okay, I've done the connection here, just putting some heat shrink over. I haven't got my heat gun, so I'll just use my lighter just to warm it up and heat shrink this so it's nice and safe. And that now can go on to our live feed down the bottom here. And now we can do the three wires for the white and connect that. And I'm going to put the main feed wire on a single terminal and the two smaller wires onto another terminal. Now what I'm meaning here is I've joined the two low ampage cables together to put a terminal on, and we'll just crimp that down. And now we'll put the heat shrink on. Okay, now we'll do the larger wire. Drop the heat shrink on. Put the terminal in. Drop the heat shrink over, and again heat that. And then what I'm meaning is the piggyback, the one terminal goes onto that one because it's lower ampage, And that now can go onto the terminal, and that is all done, ready to install. One last thing to note. The element, I actually used the earthing wire that went from the base to the element, to the earthing point on the element. The reason this is because the element is not insulated against the chassis because it has two seals. So it has to have an earth wire. So I've just made up an additional earth wire now, which I will attach on here, and then this will actually go through to the chassis. And that earth wire now can go onto the chassis. But the first thing I'm going to do now is put it up on the workbench and turn it on to actually do a leak check on the appliance. And there we go, we've got a tea-urn all working perfectly. I can control it on the thermostat. I can get myself a nice cuppa out of it. And this only cost £15 to £20 to repair. I think it's absolutely ludicrous that not only manufacturers are producing machines with this built-in obsolescence, I find it ludicrous that governments are allowing this type of stuff to come into Europe. The nursing home had to spend over £400 on 2 tea-urns because of £20 worth of elements on each one, and their maintenance guy would have been able to change it at no cost. So when going out and buying a new tea-urn, I do suggest you actually check if the element is interchangeable. The thermostat is interchangeable, the tap is interchangeable, but for some unknown reason, the manufacturer thought they could get away with producing a tea-urn with a non-interchangeable element, forcing people into buying new tea-urns. It's ludicrous. We have to change the way companies think, and we need to inform governments the way that we want things in the future. Thanks very much indeed for watching this video. I hope you enjoyed it. Make sure you hit the subscribe button, and if you do need any replacement elements, please have a look at the website. If we stock the part, we'll be happy to supply. Thanks very much indeed for watching.